All right, in this video, I'm going to look at a merit problem where we don't actually know what P or D are in this case. So I've got a point that the conic passes through, which is 4P, and another point, say D units away. It's important to remember that we don't know what P or D are in this problem. They don't substitute in for a particular value, they're just like a general value, and they could represent any number. So to do this, you want to do a rough sketch of what the conic could look like, and there are many different ways of doing this. I'll show you one. And once you have a rough sketch of that conic, you can then form some sort of equation by finding the center and the radius, or a and b values if you're doing an ellipse or hyperbola. I'm going to use a circle as my example here, but the same process applies for the other conics too. So to start this, you want to do like just a rough sketch of a graph like this. This is my x-axis, of course, this is my y-axis, and let's just plot these points on here very generally. So let's just say that 4 is over here, and let's just say that P is over here, and so that point 4P is going to be right there. Now, it's important to remember that while 4 is 4, P could be any value. It could be a really large positive number, it could be 0, it could be negative, it could be anything. It appears that it's a positive value. It appears that it's pretty much the same value as 4, but it's not. This is just a quick sketch to give you an idea of what the conic could look like. And I'm going to use this to figure out what the general equation will be. Now, there's another point here, D units away. Now, that could be in any direction, left, right, up or down, or even on the diagonal. I'm going to go to the left here, but you could go anywhere. And as I said, D could be any positive distance, because it is a distance, so it could be a really big value or a really small value, and it looks like it's about 3, but of course it could be anything. So let's just say that distance there is D, and so if you think about it then, this point over here is going to be 4 minus D. But I mean, if I chose my, my other point to be up here, then that point here would actually be P plus D. But we're not going to do that. So as you can see already, the answers could be quite different depending on how you decide to tackle this problem. So if I was to do a quick sketch of a circle that went through these points, and the exact same process would follow for like an ellipse or a hyperbola, then I might do something like this. Already it looks terrible. It looks more like an ellipse actually. It is meant to be a circle, but that's okay. So that's my circle. So now what I'm going to do is try and find my equation. So we've got H, as always, K, and R because it's a circle. So to find H, we need to know the horizontal position of our center, which is here, halfway between 4 minus D and 4. So if you think about how to find the center of that, well, let's suppose we've got like a number line here, like that, like here's, for example, 3, and that's, say, 5, and I want to find the center of 3 and 5. Now, obviously, we know that's 4, but how do you get 4? What you can do is add 3 and 5 together and then divide that by 2. So that gives me 8 over 2, which of course is 4. So I add those two values and then halve them. So this value here is going to be 4 plus 4 minus D all over 2. And simplified, that is actually just 8 minus D over 2. So I can write that one in here. K is a bit easier. K is actually just P in this case. It's just the vertical position of that point because I chose to go out horizontally. And R is just half of that distance D, so it's just D over 2. You can think of D as the diameter in this problem. So we've got all our three our parameters that we need. So our Cartesian equation will just be x minus 8 minus D over 2. You don't need to simplify this at all. That is fine. Plus y minus p squared equals r squared, so that's d over 2 squared. Just put brackets around everything. Get rid of that part there so it's not confusing. And then our parametric, we've got x equals d over 2, that's our radius, cosine t, plus our horizontal position, 8 minus d over 2. And then our y value is just, once again, d over 2 sine t plus p. And that's it. We've got our Cartesian and our 2 parametric, and the graph there doesn't matter. All right, thanks for watching.